So this one exercise related to mass, volume, and density, the ATP classified. A student is finding the density of a wood by two methods. He is using the wooden rod, like you can see, it's a wooden rod. Method one, what he did, the dimension of a wooden rod are shown, as you can see on the figure. Measure the length L and the diameter. So using your scale ruler, you will measure this length L. What is the value for length L? And measure the diameter.
3.7.
3.7 and the diameter.
The diameter 1.6.
What about others? 3.7 and 1.6. So when we measure the length was 3.7 and the diameter is 1.6. And the marking scheme answer, as I mentioned, it will be different from your, because the paper size will be different. That's why you won't have the same answer. The next suggests an accurate method of measuring a diameter of a wooden rod. In this experiment, list any additional operators that might be required and briefly describe how would you determine the diameter. Like how we can determine a diameter accurately as possible. So what we can do, if you remember, if you want to measure a diameter of a circular object, we normally
can use wooden blocks.
Good. Yes, Muhammad Ashraf.
So, Mr. Bring 4 balls and put wooden blocks in a ruler and divide the length by each of the balls.
Or you have only one rod here. You don't have the pair. You have only one rod. So you can place a rod between the rectangular block. So what we'll do, we'll place a rod between the rectangular blocks
And
and measure.
calculate the difference of the length from the edges of the wooden blocks which are
Right.
near to the rod.
Right. So we can measure the value and calculate the difference in the two value to measure a diameter. So how you will score the mark, like how you can measure. So you can take two blocks, measure the gap size, like this gap you will measure by using a ruler or the scale, and this gap size will be equal to diameter. And whenever experiment is done, you should always mention repeat. So we will use rod between the two blocks, and we will measure the gap. And repeat the experiment to take an average. The next question, student uses a balance to measure a mass M of a wooden rod. Record the value for a mass. What is this value of a mass?
7.8 grams.
So that's equal to 7.8. We just have to write the same value. Then calculate the density, rho 1 of a density of a wooden rod using your value in A1, B, and the equation. So what is the equation? The equation is density is equals to 4 times M divided by pi D square and L. So you just have, for paper 6, you don't have to memorize any formula. You just have to use the values. So we have 4. What about the mass? We already we just used that value, which was 7.8.
Grams per centimeter cube will be the suitable unit.
Yeah, suitable unit will be the gram, because the mass is in gram and the volume length dimensions we took in centimeters, so it will be gram per centimeter. So pi is 3.14. What about the diameter?
1.6 power 2.
1.6 square. As I mentioned, the actual answer will be different from your because the marking scheme answered the diameter was 2, but your answer is 1.6. So I'm taking your answer is 1.6. And the length was how much?
3.7.
3.7. So 3.7. What's the final answer? Simplify the numerator separately, denominator separately, and then take a ratio or divide them. So 4 into 7.8. What's the answer for 4 into 7.8?
31.2.
So 31.2. And then 3.14 times 1.6 square times 3.7. What is the answer for this denominator?
29.74.
And when you divide 31.2 divided by 29.74, that will give us the density, which is
1.05.
so 1.05, and the suitable unit, as you mentioned in the beginning, gram per centimeter cube. Why gram? Because the mass was in gram and the dimension of the lengths were in centimeter. So gram per centimeter cube. In method 2, student pour a water into a measuring cylinder, as you can see. Student pour a water into a measuring cylinder. He then float the wooden rod and he record the value V1 and V2. You can use the screen annotation to complete this value for V1 and V2. What is value for V1 and what is the value for V2? Use the screen annotation to complete this. Value for V1, 138. How 138? It is above 140 because this is 140. This mark is 140. It's two lines above 140. So it will be 144. And this is 152, right? So 152 and 144. Then the student remove the rod and lower a piece of a modeling clay. So they like, because wooden objects, they can easily float. That's why it won't be that accurate. So what student did, remove the rod and lower the modeling clay into a water. He then hooked the rod into a modeling clay and lowered them together. The new value for volume 3, this is V3 and this one is V4. Then student calculated the density. The second density student calculated by using a formula. Modeling clay, it can be any object. What is the purpose of using this modeling clay? Because what will happen, say if you have a measuring cylinder and that is filled with water and you want to work out the volume of the wooden object. So if you want to work out the volume of a wooden object, that wooden object will float. So it won't be accurate. It should be completely submerged. So to completely submerge, what student did, student attach a modeling clay to this. So this modeling clay will take this piece of wood inside the water.
It will submerge so the accurate volume can be measured.
It will submerge so accurate volume can be measured. Otherwise, if only rod is placed, it won't be accurate because that's not completely submerged. So purpose of the modeling clay is to sink the wooden rod. Yeah, it will have its weight, but the thing is, we don't bother about weight. We want to measuring cylinder is used to calculate the volume. How much volume displaced, that is equals to volume of the object. Like this is a volume of water and clay. This is a volume of water, clay, and rod. So when we subtract these two, we'll get the volume of the clay. It will increase the volume more, but this is a volume of water and clay. This is a volume of water, clay, and rod. So if we subtract these two, we'll get the volume of the rod. But as I mentioned in paper 6, you don't have to memorize the formula. You just have to follow the instructions. So you have to calculate the new density, that is V2 minus V1 divided by V4 minus V3 into K. So V2, it was, I guess,
152.
152. So this was 152. minus V1 was 144.
144, yes.
V4 was 178 minus 164. And times K. What is the value of the K? K is equals to 1. So this is multiplied by 1. So that is 8 divided by 14 into 1. What's the value for the second density?
So
0.57.
Mr. 0.57.
And the unit again, it will be gram per centimeter cube. So 0.57 gram per centimeter cube. Then in part E, on a figure, draw an arrow to indicate the correct line of sight for a reading the water level. You can use a screen annotation to annotate this on the screen. So that's right. So we should look perpendicular. You will draw an eye. No, eye level should be in bottom of the meniscus. Like when you draw the eye, it should be on the level, because otherwise if you place an eye, means there will be a parallax error. So this is not the right. When we are reading it, we should always look for a bottom of the meniscus. So position of eye is important as well. It should be in line with the lower bottom of the meniscus. Suggest a possible source of inaccuracy in method 2. Method 2, what might be inaccuracy? If you see the method 2 student did. In method 2, what student did? Student using in the like tie this wooden rod with a string and then
So Mr. the rope may be thick.
so volume of the spring is there. That is one. What else? The modeling clay. What might happen? Like another thing, like this wood might absorb some, because these objects can absorb
The modeling
splashing.
clay can have trapped air.
Yeah, modeling clay can have trapped air. So when that air, that's right. That is one of the reason. Or modeling clay may absorb some of the water. Wood might absorb some water. And splashing you mentioned. Okay, that the question is suggests a possible source of inaccuracy. So many possible answers are there for this question. Suitable source of inaccuracy means, like this is an open response question. You can mention trapped air in a modeling clay, or wood might absorb some water, or some water might be lost, that you mentioned, like splashing. That is correct. Is it clear discussion?
Yes, sir, clear.
Moving on to the next question, question 3. It's only one part is there. Figure 2.3, draw a line and an eye to show clearly the line of sight required to read the volume of the water. And one more thing, when the side where the scale is there, the markings are there, try to draw the eye at that position, okay? Because that's a right way. You don't have measuring cylinder, won't have all around it the scale, only specific position there is a marking. So if the markings are there on the right hand side, you should draw eye on the right hand side. If markings are on the left hand side, draw the eye on the left hand side. Draw an eye on the left hand side. So previous question, why we did draw the eye on the left? Because the markings were on the left. This question, the markings are on the right. That's why we are drawing on the right hand side. The next question, volume of the water used to measure, volume of a water used in this experiment, measure using a measuring cylinder. Figure A, B, C, D are the 4 possible positions. 2 reasons. Give 2 reasons why B should be obtain the most accurate reading. So B, because it's reading bottom of the meniscus, that's right, one way. What about other? Yeah,
Because it's parallel to the scale.
Perpendicular to the reading. Perpendicular, 90 degree. Because if you check, this is making a 90 degree. Not parallel, so it is perpendicular to the scale. And another thing you can say, because this is by, it is also accurate because that is a side where there are markings. So you can mention bottom of the meniscus, reading a bottom of a meniscus, or looking perpendicular, avoiding a parallax error, and the side where we have marking, that side we are reading. That's why it's more accurate position. Moving on to the next question. Question 5. Students measure, because this exercise we are doing, the questions only related to mass, volume, and density. Paper 6 question. The student measure the mass of a rule on a balance. Write down the mass shown to a nearest gram. So 112.65. So it is 113 gram. Calculate the weight W2 of a meter rule by using a formula W equals mg. So mass into gravity. Why this is wrong? Because whenever
You
you're
said
using,
kg.
whenever you're using a
Okay.
formula, the mass should always be in kilogram, but this mass is in gram. So you have to convert into kilogram first, because it's written 10 Newton per kilogram. So this could be kilogram. You divide by 1000. So it will be 0.113 times 10. So it will become 1.13. State and explain whether the W2 can be considered equal to W1 obtain. This is because I just only took part of it. In that one, you have to complete W1 with W2. Like example, say if I say W1 is 1.1 and W2 is 1.13. Can I say they are equal? Yes or no?
Yes.
So I can say yes, the two values are equal within limit of experimental accuracy. Because this part W1 is from the previous related to balancing experiment. So I did not include that. This question is only related to density. So we just compare W1 with W2, our answer according to the full question. The next one, question 6. So you can leave this part because this one is, this part state and explain whether the value W2 can be considered as equal to W1. W1 you will find in the balancing experiment, because this is a part related to balancing experiment as well. So just I mentioned, say if a W1 is 1.1 and W2 we calculated 1.13. So can we say they are equal? So yes, you can say they are equal within the limit of experimental accuracy. This statement is there within limit of experimental accuracy. W1 and W2 are equal. But what if, say W1 was 0.7 and W2 is 1.13? Can I say they are equal? Yes or no?
No.
No. So you will say no, within limit of experimental accuracy, the two values are not equal. Question 6, student determine the density of a modeling clay by two methods. First method, student shown one face of a piece of a modeling clay that student uses, that is sample A. Student measure the depth, which is 3.2. Then measure and record the length and the width of a modeling clay. What is the length and the width of this modeling clay? Length is 2.8, and what about width? Width is 2. Okay. So the marking scheme answers, as I mentioned, it will be different, but we will just use our answers, that is 2.8 and 2. Then calculate the volume VA by using L into W into D. Paper 6 just use the values, like this was 2.8. This was 2. So what we have to do, length, which is 2.8, times width, which is 2, times the depth, which is 3.2. What's the answer when you multiply all of them? So you will get
17.92.
17.92. 2.8 times 2 times 3.2.
Yes,
17.92
Mister.
centimeter cube. The length you got 2.7. Okay, so what you get, you will use accordingly. So you will use your answer. Don't bother about the answers of other. You just use your answers. Then the mass is there. Record the mass to a nearest gram. So 51. So this is 51. And next we need a density mass divided by volume. What is the mass? Was 51. And what about the volume? According to your, like 17.97 was there. Use your value 17.92 was 92. What's the answer for density in gram per centimeter cube?
2.84.
So 2.84. 2.85, 2.84. What is the next number after 2.8, after 4? Is it 6?
5.
5, so it will be 2.84. Okay. The next one, the method 2, student record the volume of a measuring cylinder. Like this is the displacement method student use. Student fill the measuring cylinder with a 150 cm cube of water. Then he add a modeling clay to that. So first there's a volume of the liquid and then the volume of a liquid plus the modeling clay. And then took a difference to get the volume of the modeling clay. So the question is, you can use the screen annotation just to complete. What is VB? The difference. So that is 32. Then the 32 is there and then 60. So 32 divided by 60. What's the answer? So 1.87 gram, and the unit you should write your answer in 3 significant figures. So it will be 1.88 because before 5 there is 7, the odd number. So 1.88 gram per centimeter cube. So a student suggests that the density of a modeling clay is not affected by mass or volume. Like density won't change even any method we use. We should get the same density. What was the answer? The first density, this one.
2.84.
2.84, yeah. And this is 1.88. So we have to compare our result. Even practical, like according to theory, yes, it should be there that the density should not be affected by the type or the size which we took or the mass. It depends on the type of material. So here we have 1.88 and the first density when we use the first method, we were getting 2.85 gram per centimeter cube. So you can see when we change the method, we are getting a different density. So students suggested that the density of a modeling clay is not affected by mass or volume. State whether your results agree with the suggestion and justify by reference to your results. So we'll say no. Student suggestion is not correct. According to our values, why student suggestion is not correct according to our value? Because in the first experiment, when we use the method 1, we were getting a density as 2.85. But for the same modeling clay, when we use a method 2, we were getting a density as 1.88. So it means that for us, it looks like when we change the method, the density changes. It should not change, but it is changing according to our value. So you will always write answer according to your value. Is it clear, this part?
Yes,
Yes,
sir, clear.
So it is like justification. You can mention that like the two values are not equal or they are beyond the limit of experimental accuracy. Like it's more than the experimental values are cannot have too much variation. The next, tick the boxes, describe the correct answer. So we have to tick a boxes. I will read the question. You will use the screen annotation. Just a minute. Let me just arrange. Yeah. You have to tick the describe taking a reading. So what we should do to avoid a line which is called a meniscus along the scale. We should look perpendicular and in line with the bottom of the meniscus. That's right. So we should always look perpendicular. We should always look in line, like in line with the bottom of the meniscus, like our eye level. So this was the last part of topic density.